So once given an overview of these orbital energies, we can now put electrons into those orbitals. And there's two main ways that we represent this. And we typically use electron configurations and orbital block diagrams to indicate where the electrons are in the particular orbitals. So let's say a couple things first, and that is that each orbital can hold 2 electrons. Okay? And if orbitals have the same energy, we call them degenerate. So that's a term that we're going to use throughout the rest of this chapter. So if we have a particular orbital that's either degenerate or has the same energy, we know from Hund's rule that electrons are going to spin up first, then they're going to go in spin down. So let's kind of talk about this electron spin a little bit more. Okay, so with electron spin, we can say that electrons have a charge, and that charge is negative. These electrons are also in constant motion. So we have 2 negatively charged particles in constant motion, and this creates a small magnetic field. And we can say that if we have 2 electrons and they're really close together in the same space, they're going to do everything they can to minimize the amount of repulsion. So what happens is we have 1 electron here that's going to spin in the north direction, and we have another electron over here that's going to spin in the opposite or the south direction. And what's going to happen is that electrons spin in opposite directions, minimizing repulsion. This lowers energy, making the atom more stable. We don't refer to this as north and south spin when we discuss electrons. Like I said in a previous video, we refer to this as spin up and spin down. And typically we will represent 1 electron with an up arrow and another with a down arrow. And this is what the electrons will do in an atom to make it more stable. Okay? So since this arrangement of electrons dictates the overall energy of the atom, we need a notation to describe the arrangement of these electrons. And there's 2 main notations that we use. We use electron configuration, which simply tells us how many electrons are in a particular orbital. And we also use orbital block diagrams. The block diagrams also tell us how many electrons are in a particular orbital, and it's also going to tell us which particular orbital that they're in. So the block diagram will give us a little bit more specific information. And quantum mechanics allows us to calculate the energy of the orbitals, but electrons are very, very lazy. And in both of these cases, the electrons will always fill up orbitals to minimize the total energy. So we're going to get the lowest energy value that we can for all of these electrons occupying various orbitals. And in the next video, I'll go over the ground state electron configuration and orbital block diagrams for the first 18 elements.